Our story begins with a tiny sphere, a single cell barely visible to the naked eye. This cell, though minuscule, holds the potential to create an entire human being. This is the ovulated oocyte, often called the egg, a woman's contribution to the miracle of life. It is a marvel of nature, a single cell that carries within it the promise of a new beginning. Released from the ovary, a protective sac called the follicle bursts, sending the oocyte on its journey. This release is a critical moment, setting the stage for what comes next. This is ovulation, a monthly event orchestrated by hormones. These hormones work in harmony, ensuring the oocyte is released at the perfect time. The oocyte, carrying half the genetic blueprint needed to create a new human being, now embarks on a perilous journey, traveling down the fallopian tube. This journey is fraught with challenges and uncertainties. Its destination, the uterus, the potential cradle for a new life. The uterus is a nurturing environment ready to support the development of a new human. The oocyte is no passive traveler. It moves with purpose, driven by the forces of nature. It carries within its cytoplasm, the cell's inner space, a treasure trove of nutrients, enough to sustain a growing embryo for the first few days. These nutrients are vital for the initial stages of development, but time is of the essence. Every moment counts in this delicate process. The oocyte has a limited window, about 24 hours, to meet its fate. This narrow time frame adds to the urgency of its journey. Will it encounter its counterpart, the sperm, and begin the incredible process of creating a new life? The meeting of these two cells is nothing short of miraculous. Or will it fade away, its potential unfulfilled? The outcome hangs in the balance. The stage is set for a microscopic drama to unfold. Each step in this journey is a testament to the wonders of life. The fallopian tube, a delicate tube connecting the ovary to the uterus, is the setting for this crucial encounter. It is within this narrow passage that the journey of life begins. Millions of sperm, tiny cells propelled by powerful tails, will have made the arduous journey, but only one will win the prize. These sperm cells navigate through the female reproductive tract, facing numerous obstacles along the way. The successful sperm, guided by chemical signals, will penetrate the oocyte's outer layer, the zona pellucida. This moment marks the beginning of a new genetic combination. This triggers a series of reactions, effectively blocking other sperm from entering. The egg surface changes, ensuring that only one sperm can fertilize it. Fertilization, the union of two gametes, has occurred. This union is a pivotal moment combining genetic material from both parents. This fusion creates a single cell, the zygote, containing the complete set of chromosomes, half from the mother and half from the father. The zygote is the first cell of a new individual. The zygote is no ordinary cell. It carries the genetic blueprint of a new individual, a unique combination of traits passed down from both parents. This genetic blueprint will guide the development of the embryo. This microscopic entity holds the potential for life, a life that will unfold in a series of carefully orchestrated steps. From this single cell, a complex organism will eventually emerge, showcasing the marvel of biological development. Inside the zygote, a remarkable dance is about to begin. The nucleus of the sperm and the nucleus of the oocyte, each carrying half the genetic material, draw closer. These are the pronuclei, destined to merge and pool their genetic resources. Their fusion marks the creation of a new genome, the complete set of genetic instructions that will guide the development of the new individual. As the pronuclei fuse, a spindle of microtubules, tiny protein fibers, forms between them. This is the first cleavage spindle, a structure crucial for cell division. The stage is set for the first division of the zygote, a process called cleavage, which will ultimately give rise to trillions of cells that make up a human being. The zygote doesn't waste time. About 30 hours after fertilization, the first cleavage begins. The single-celled zygote divides into two daughter cells, each smaller than the original but containing a complete copy of the genetic material. These cells continue to divide from 2 to 4, 4 to 8, and so on, in a process called cleavage. These divisions occur rapidly, without any significant growth in the overall size of the embryo. The cells, called blastomeres, become smaller with each division, but together they are still enclosed within the protective zona pellucida. By day 3 or 4, the embryo resembles a mulberry, a cluster of 16 or more cells. This is the morula, named after the Latin word for mulberry, marking the end of the first stage of development. Section 5, from morula to blastocyst, a crucial transformation. The journey from the fallopian tube to the uterus continues. Inside the zona pellucida, the morula undergoes a remarkable transformation. Fluid begins to accumulate between the cells, creating a cavity called the blastocoel. This fluid-filled cavity is crucial for the next stage of development. As the blastocoel expands, the cells of the morula rearrange themselves, forming a hollow sphere. The cells on the outer layer will become the trophoblast, responsible for implanting the embryo in the uterine wall and forming the placenta. A small cluster of cells inside the sphere, called the inner cell mass, will give rise to the embryo itself. This is the blastocyst, a structure remarkably different from the morula, poised to begin the next chapter in its journey. Section 6, ready for nesting, the blastocyst prepares for implantation. The blastocyst is not just drifting, it's on a mission. Around day 5 or 6, the blastocyst breaks free from the confines of the zona pellucida, a process called hatching. This allows the blastocyst to interact directly with the uterine lining, preparing for implantation. The uterine lining, primed by hormones, becomes receptive to the blastocyst. The trophoblast cells, now in direct contact with the uterine lining, begin to invade the endometrium, the inner lining of the uterus. This is the beginning of implantation, a complex process that marks the establishment of pregnancy. Section 7, a week of wonders reflecting on pre-embryonic development. From a single cell to a complex structure ready for implantation, the first week of development is a testament to the remarkable power of life. This period is a whirlwind of activity where every moment counts and every division is crucial. The zygote, a single cell formed by the union of sperm and egg, has undergone a series of transformations, each step precisely orchestrated. These transformations are not random but follow a highly regulated sequence. Cleavage, the rapid cell divisions that increase cell number without increasing size, transforms the zygote into a morula, a cluster of cells resembling a mulberry. This stage is critical for the next phase of development. The morula then transforms into a blastocyst, a hollow sphere of cells with a distinct inner cell mass and an outer layer called the trophoblast. This transformation is essential for the blastocyst to implant into the uterine wall. This first week is not just about cell division and differentiation, it's about laying the foundation for all future development. Every cell, every division, and every differentiation sets the stage for the complex organism that will emerge. The blastocyst, with its inner cell mass destined to become the embryo, and the trophoblast that will form the placenta, represents the beginning of a new human being. This intricate process is the dawn of life, a marvel of biological engineering. Section 8. The journey continues, gastrulation and beyond. The first week of development may be over, but the journey is far from finished. Implantation marks the beginning of the embryonic period, a time of rapid growth and differentiation. One of the most critical events during this period is gastrulation, a process that establishes the three primary germ layers, the ectoderm, mesoderm, and endoderm. These germ layers will give rise to all the tissues and organs of the developing embryo. The ectoderm will form the skin, nervous system, and sensory organs. The mesoderm will give rise to the muscles, bones, circulatory system, and reproductive system. The endoderm will form the lining of the digestive system, respiratory system, and urinary system. Section 9. Unlocking the secrets, the importance of understanding early development. The first week of development, though seemingly invisible to the naked eye, is a period of profound significance. Understanding the intricate events that occur during this time provides insights into the very beginnings of human life. It's a testament to the power of science that we can now trace our developmental journey back to a single cell, the zygote. Studying early development not only satisfies our curiosity about the origins of life, but also has practical implications. It helps us understand the causes of infertility, birth defects, and developmental disorders. This knowledge is crucial for developing new treatments and therapies that can improve reproductive health and ensure healthy pregnancies. The more we learn about these early stages, the better equipped we are to safeguard the health of future generations.